Now, this second law, the second law is saying that it's a little bit different. Actually, it's different from the first law. Now, what is the second law telling us? On the board, we have Newton's second law of motion. It states that the rate of change in momentum with time is proportional. Change in momentum with time is proportional to the applied force and take place in the direction of that force. So the momentum is directly proportional to the applied force with respect to time, and it also takes place in the what? The direction of the force. That is what the Newton's second law. So mathematically, we actually apply this mathematically. Use this to solve questions. So mathematically, what Newton is trying to tell us is that change in momentum. What is change in momentum? Now, change in momentum itself is mass times velocity. Mass times velocity. In this particular topic, we are going to treat momentum in full. But for now, let me just use this and explain. Now, momentum, the change in this momentum. Momentum itself is mass times velocity. Change in momentum is mass times, that is, let's say, change in mv. Change in mv. So, change in momentum. Momentum is equal to mass times velocity. Change in momentum with time means change in mv with time. Change in time. So, change in momentum with time, which is this, is directly proportional to the applied force. So, what the man is saying is that, or you can see that applied force, F, is directly proportional to what? Change in momentum with time. That is the second law. So, we have that force, if I remove the sign of proportionality, I put the equality sign, put a constant K. Now this changes to M V minus U, that is change in velocity, divided by change in time. Now, K is a constant of proportionality. In this case, where K equal to 1. K is equal to 1. So if K is equal to 1, that means that our formula now remains that force is equal to M V minus U divided by T. F equals M into V minus U divided by what? T. V here stands for what? Final velocity, while U here stands for the initial velocity. This is mass, and this is the... Now recall that acceleration is equal to V minus U over T. So I'm going to clean here. So acceleration is equal to V minus U over T. So if that is the case, I'm going to replace V minus U over T by acceleration A. Therefore, force is equal to mass times what? Acceleration. So this is where the original, this formula, mass times acceleration, is coming from. It is actually coming from the second law of Newton, as we have seen. As we have seen, it is well proved that force is equal to mass times acceleration. Now, another concept of this that we are going to touch later is impulse. Remember, F is equal to mv minus u divided by t. Now, if I cross multiply, I have that ft is equal to N into V minus U. From what I showed you initially, this is change in momentum. Ft, force times T, is called impulse. It is called impulse. Force times time is called impulse. So from here now, from Newton's second law of motion, we can see that impulse is equal to what? Momentum. Impulse is equal to what? Momentum. So I can bring this down and say that Ft is equal to mv. mv, where this v is equally, I'm using this to replace the general view if you just take your changing. So we can define impulse as the product of force applied and time taken. And time taken to what? Apply this force. So impulse is defined as the product of force applied and the time taken. Please note this, very, very important. Impulse, we can use I to denote that, is equal to change, or simply is equal to momentum. Impulse I is equal to momentum. Impulse is equal to momentum. Be very, very careful with that. Sometimes they will ask you to dimension that. Yes, they can. They may ask you, which of the following has the same dimension analysis as momentum? They will list energy, impulse, and so on and so forth. Because impulse is equal to momentum, impulse and momentum have the same dimension analysis, or outcome of what? Dimensioning. Please note that. So we are going to solve questions concerning this in the exercises section. Okay, now we have an example on the board. So let's use this particular example to see how to apply this formula concerning the formula we got from the second law of motion, second equation. So let's see what we are going to do now. First of all, remember, for more exercises, more solving, just go to the exercises section. You see numerous questions. This particular one is just to see how to dive into the formula. Now, let's go. So if we put down our solution, let's read the question to understand. They said, when taking a penalty kick, a footballer applies a force of 30 Newton for a period of 0.05 seconds. Always take note of the units. If the mass of the ball is 0.075 kg, calculate the speed with which the ball moves off. So in this particular question, we are looking for what? Speed. Now, when you are given this kind of motion question, some people don't know when to apply the law. They keep asking this, which law am I supposed to apply? Just write out the parameters. It will lead you to the law. We have force F, 30 Newton. We have time, or in correct unit, 5 seconds, 0.05 seconds. We have the mass, M, 0.075 kg, also correct place. If this is not in kg, if it's in grams, convert to kg. If this is not in seconds, if it is in minutes, hours, convert, then this is properly the way it is. Now, then what else do we have? We are looking for what? V. So I should tell you, in which formula in physics involves time, force, mass, and velocity? That is the Newton's second law of motion. So what you are going to say, the law says that F is equal to mv divided by what? T. mv divided by t. And we are looking for v, so v is simply ft. If you cross multiply, make v the subject of the formula, divided by what? M. Simple substitution. F is 30 times time is 0.05 divided by mass, which is 0.075. So if you point this in your calculator, you get, we have the way with questions are twisted in the exercises section. You will just, if you click on that, you see many questions on that. So let's finish this. 30 times 0.05 divided by 0.075. So when you divide, we are going to get 20 meter per second. 20 meter per second. Remember, this question can be twisted in any form. They can ask you anyone they like. They can ask you to get mass. They can ask you to get time. They can ask you to get force. It depends on the question. Go to the exercise section. We have numerous questions concerning this. Let's quickly go over now to the Newton's third law of motion.